What's up, friends? Today we are here with a slew of boards. Today we're going to be testing the PSPEC on the Atlas Pro, the Flex Pro, the X1 Max, and the Wave down there. I also have the Meepo V5 here, which is not part of this video. I just happened to be testing it at the same time. So yeah, we're going to get all the results for the PSPEC on each of these boards, excluding the range. I will have to do that a separate day, obviously, because that will take a long time. But we're going to be starting right now with the torque test. If you have not seen my PSPEC scoring before, I encourage you to check out one of my reviews. I did a review on the Rebel kit with the PSPEC and the Flex ER. So those are both available in the description or on the pinned card. So yeah, we're just going to go ahead and get started. Each of these boards will be getting measured for their stall torque at 0 miles per hour. Now, this is not a complete representation of the acceleration of the board, but that's why we use it in combination with the 0 to 20 time as well as the braking. So you can kind of get a good idea for what the maximum torque is of each of these boards and then compare them directly to each other. To measure the torque, basically what I do is I take my crane scale, I hook it up to the rear of the board, hook that up to something solid, aka the pole that you guys are attached to right now, and we just pull until the board stops pulling, and then we take down that measurement and do some math to convert it back into the torque at the wheel. So let's go ahead and get started. I think we're going to go ahead and start with what I think will be the weakest board, the X1 Max. So let's go. Alright, so for this testing, it's pretty simple. Basically, I just go ahead and ease onto the throttle and let the board pull as hard as it can. Now, I did this testing for all of the boards in this video, and basically what I'm going to do is I'm just going to have a little bit of footage of the board, do some voiceover, and then I'll show you the numbers from each board, and then after we've seen all of those, I'll compare them on a chart together. In addition to all of these boards in this video, to round out the Exway testing, I also got the data for the Exway Ripple, which is their new shortboard. So let's go ahead and take a quick look at the numbers for the X1 Max here. For the X1 Max, we came out to an average torque of 9.59 Newton meters. Along with that, we got a max of 9.77 and a minimum of 9.33. Now, these are all pretty close together, which is to be expected from a current limited ESC. Now, to calculate this, it's pretty simple. Basically, I take the moment arm, which is the distance from the wheel point where I measure the torque to the center of the axle, and using that and the pull force, I'm able to calculate the torque applied to the wheel. So I've got this for all of them, and we're gonna just keep on going on. Testing for the Wave went on about as I expected. No wheel spin or anything like that. Scale stayed in place, and we were able to get all of our numbers. So the numbers for the Wave actually ended up being a little bit lower than the X1 Max, which is quite interesting to me, coming in at an average of 8.96, a max of 9.09, and a min of 8.77. The reason why this is interesting is because the Wave is on a belt drive, so I have to wonder if the ESC is tuned a little bit differently than the X1 Max. But we'll see how they compare in terms of acceleration and see how it uses that difference in torque. Alright, we're testing the Flex Pro now, and this one I'm expecting to be by far the most exciting. This has really great starting torque for a urethane board, and I wouldn't be surprised if we might overcome the traction of the urethane here, but I'm going to stand as far back as possible to make sure that that doesn't happen. So let's go ahead and test these numbers. I'm a little bit concerned about this one. I think it might break something. Yeah, we are in turbo mode. Alright, here we go. Torque testing the Flex Pro. Let's see what happens. Oh boy. So basically, I was having some issues with traction here, and after the scale came loose, I went ahead and tied it back up properly, and with my helmet on in case of something glitching out and falling, I went back to testing and I was able to get some max torque values from the scale right before the wheel starts slipping, which is what I took as the maximum torque. And you can see that one side has a little bit better traction than the other, so I'm pretty confident that we got pretty much the maximum performance out of this ESC. So let's see what those values were. Comparing to the last 3 boards, we come in at a massive 19.65 Newton meter average with a max of 21.4 and min of 17.61. Now, this is not a completely perfect test due to that slippage we had, and that slippage may have also caused a little bit more variance here, but I think these tests are still the best I can get for now, so we're going to use them. Now, the question is, will this double amount of torque result in double amount of acceleration? Well, we'll see in a little bit. Next up is the Exway ripple before we move on to the Atlas Pro, and we got the little ripple here, and for the numbers, we got pretty much the lowest ones that I have seen on a board to date. So we're just gonna go ahead and go straight to the chart for this one, and here are the numbers. To give some background into these small numbers that we have here at 5.83 average, 5.9 max, and 5.7 min in terms of torque. The Ripple is Exway's cheapest board. It's also a brother to the Wave, which is a short board. So, you know, it's going to have lower power. And on top of that, it's got 75mm hub motors, which is some of the smallest hub motors I've seen on any e-skate at all. It gives you kind of a perspective for these numbers. Now, coming up next, we have the Atlas Pro, and you'll see, spoilers, that the torque is nearly 10 times what the Ripple has. So with its lower powered Lingy ESC, I think that it's really aimed at beginners. Alright, so we've got the Atlas Pro here, and this one is the one I'm expecting to be the strongest of the bunch because of the gear drive and the gear ratio and the bigger motors and the fact that it has the same ESC, I think, as the Flex Pro. So I'm actually going to start in mode 3 here and do a quick test to see if we break traction in mode 3. So we break traction in mode 3, then we're going to be limited by the traction of these tires. So let's just see what happens in mode 3. All right, here we go. Weight over the rear wheels. 69. Wow. 70. Okay, well, let's switch this to turbo mode and see how this goes. All right, kind of nervous. 123. 128. Man, the whole rear end is flexing. All right, one more. 125. Oh man, this one. The entire rear end of the board is flexing. As I was sitting there, the Atlas Pro comes in with an enormous amount of torque at 53.67 max, 50.65 average, and 48.35 minimum for Newton meters of torque. Now, the Atlas Pro was actually flexing the entire deck and truck mechanism on each of these poles, so that was quite nerve-wracking, but no damage was done, so that's pretty great. And this enormous amount of torque led it to give some pretty great results in the acceleration testing as well. So let's go ahead and look at all of the torque results compared together on one graph. Let's take a moment to talk about this full torque comparison. Now, since we're comparing the actual torque of each of these boards, it ends up ignoring the wheel size, or taking it into account rather. So the numbers you see here are what torque the motor itself is outputting to the ground. So you'll see here that the motors on the Ripple put out a very small amount of torque compared to the motors and the ESC on the Atlas Pro. So this is all information that is great to see and compare all these boards directly, so you know what you're getting for your money, and in the future, in other reviews, you will be able to compare these to all of the other boards that I test. In fact, I'll go ahead and put on the other boards that I tested in the past, just so you can see them real quick, and then move on to the acceleration testing. So as you can see here, I have all of the values from all the different boards that I've measured, and that includes phase 1 of my race board build. Now, the race board now is much more powerful than it was when I tested it at this point, and at this point I was having some major issues pulling that amount of torque against a pole. So I'm going to have to devise a new method to make sure that I don't break any trucks and I don't break my equipment. So that race board torque may get reevaluated in the future, but all the rest of them are accurate, and it's pretty interesting to see all these numbers. So let me know what you think down in the comments below, and move on to the acceleration testing.
Oh my goodness.
On the screen now we have 5 perspectives from the first 5 runs of the 0 to 20 and 100 meter sprint times on these 5 boards. Now, I'm only going to do 1 round of these, so pay attention real close, and then we'll just go straight into the numbers because, you know, it's the same thing 4 times. You don't need to see all of them. So here we go. Alright, let's talk a little bit about the acceleration on the Ripple. Now, this is an interesting case because the Ripple can barely make it to 20 miles an hour. Now, I know it's advertised to go a little higher than that, and to be honest, I couldn't even figure out how to switch the remote into miles an hour. Granted, I didn't look very hard, but I used the miles per hour on the GoPro to do these testing anyway, so I was barely able to reach the 20 mile an hour mark, which is why this has an asterisk by it. I was only able to reach 19 miles an hour in the allotted time. Now, going over to the Wave, this was also barely able to reach 20 miles an hour. And in fact, you'll see it hit 20 and then droop off to 19 again. So I did get a 0 to 20 time here, and I was able to do it a couple of times to get those 4 results and the average, but still not great. So if you're looking for a faster shortboard, this isn't it. Stepping up to the class of longboards, we have a much more interesting comparison between the X1 Max, the Flex ER, and the Flex Pro. On screen you can see all of their results, and the Flex Pro puts up a pretty impressive showing. Now, I did have the results from the Flex ER already, so I decided to include them on here to compare them to the very similar, surprisingly similar in fact, X1 Max, which is a hub board, but it's from a more recent version of the Exway boards. Now to our final competitor that puts up the most impressive performance, the Atlas Pro versus all of them. Now this chart is the opposite direction with the shortest speeds, or shortest times at the top and longest at the bottom. Now, these are the accelerations from 0 to 20 miles an hour, and you can tell there's an enormous difference between this powerful longboard and the short boards at the bottom. Now, the Atlas Pro is an extremely fast board, and of course your mileage may vary depending on rider weight and elevation of your track and whatnot, but I had really good results with it, and these are the numbers that I got. Adding on the other boards that I've tested over time, we can see quite an interesting layout here. Now, I do have to commend the Atlas Pro for being as fast as it is, and if you haven't tried one out, I suggest you try one because they're a lot of fun. Now, my race board phase 1 was a 14S board at 40 battery amps per side, and I have to imagine that's actually kind of similar to what the Atlas Pro is running. So it's interesting to see those times being so close together. Now, I was having some issues, and I was a little nervous to go full pin with the race board at the time, but, you know, I've upgraded it since then, so I'm going to have to redo this with the phase 2 upgrades anyway. Now, all the other boards did well. In fact, the Flex Pro is just as impressive as the Atlas Pro because it's a urethane board, and honestly, I don't need a whole lot more power than the Flex Pro has on a board like that with small urethane wheels. So hopefully you guys find this data interesting. I do like doing these comparisons and getting to see exactly how the data works out, especially as we get more new boards in the future and add them to this 0 to 20 time tests. Now, our second part of the acceleration testing for boards is the 100-meter sprint, and we end up with nearly the same order here. And this is something that can often be limited by top speed, and you'll see that most of these boards actually do hit that top speed before reaching that 100-meter line. Now, my race board has a top speed of 35 miles an hour, or at least it did in that configuration, and I was not quite able to hit that before crossing the line. So it'd be interesting to see a 0 to 30 time in the future, but that one is pretty risky, especially for boards with less stable trucks. So hopefully you find this data interesting, and we'll move on to looking at the data for the braking tests. Now, braking testing is quite interesting and another one of those risky ones. So for keeping myself safe, I chose to do braking tests from 15 miles an hour to 0 on all of these boards. And that's going from a full 15 miles an hour to a full brake as hard as possible. Now, let's go ahead and take a look at some of the data for these braking tests. As I mentioned, braking is quite interesting, and the Atlas Pro is very good at it. One of my favorite things about the braking on the Atlas Pro is that you can actually brake traction. And what that means is you're able to take the maximum performance of those tires right to the edge. And that's actually pretty similar for the Flex Pro. You get kind of a weird vibration when you brake traction on urethane. So watch out for that when you're braking, especially if you're doing max power braking like this. The rest of the boards, well, they're weaker, smaller, so a lot more distance in that braking from 15 to 0 miles an hour. Now, the only other thing I really have to say about this is that I would love to do higher speed braking to see how that does, but it's just way too dangerous, especially on boards that I have less than 100 miles on. So maybe I'll do it in the future, but not quite yet. As for the other boards that I've got on deck, I have the Onboard DIY, Meepo V5, my race board, and the Rebel Kit. So quite interesting here. Well, not too surprising, but my race board has the best braking distance by far. That's one thing that VESC-based boards are really good at, is really great braking. And in fact, I didn't actually have the braking tuned super high for that board, but not too surprising anyway. You can see the Onboard DIY, another hobby wing board, comes right in the middle. It's got 6-inch wheels on it, so got that belt drive reduction, a little bit less braking power than some of the newer ones like the Atlas Pro. The Meepo V5 was kind of a weird one, coming in above a lot of the other ones with a shorter brake distance, but I think that's something to do with the fact that it has the steady hold braking, which once it gets to a low enough speed, it'll just lock the wheels in place. I think that happens right when you hit 0, but some of these other boards have a tendency to roll at their slowest braking speed. So there you go, there's that information, and we'll continue adding to this as I review more boards. So for the top speed testing on these boards, I didn't actually do it on camera because I need to do it on smooth roads, and I kind of just did it when I had time. So I have all the top speeds listed out for these boards, and I've got the average, min, and max that I was able to get, and some of them were pretty close on their average, min, and maxes. So let's take a look at this data. Now, the first thing you're always going to notice is that the race board is much faster than any of these. The second thing you might notice is that the Atlas Pro and Flex Pro are actually quite close in their top speeds. Now, I expected the Atlas Pro to go a bit faster, but I was really only able to get between 28 and 29 miles an hour on average. And I think that is partly due to rider weight, partly due to the PSI of the tires, and I don't know. I mean, it's close to the advertised speed, so not really any huge complaint there, but I expected it to go a little faster. One thing here, the Rebel Kit is keeping up really well with the newer boards, which is interesting given how old it is. And the other boards at the lower end, well, they're a lot cheaper, so you should expect less performance from them in the first place, but still not a bad showing, and all these boards have more than enough speed for most people. Now, even though the short boards only go like 20 miles an hour, it feels a little bit faster than 20 when you're actually riding them because they're so short. So there you go, there's the top speed testing, and that's the final bit that we're going to talk about before we go into the PSPEC scores. Alright, now we have the PSPEC score, and strictly speaking, the score itself is slightly subjective because I have 5 metrics and they are weighted. Now, I chose the weighting of these based on what I think is most important in a board, with the top 2 being range and acceleration, and then followed by braking and top speed and torque. Now, all of the numbers that I get and put into the chart before the PSPEC score are objective, and you can see here what all of those numbers come out to. Now, this is quite an interesting comparison to see because we have a metric that combines all of these different things and allows you to directly compare the boards. And then if you want to, you can even compare this to the price. Now, I haven't really worked out a good ratio of price to performance that scales well, but I'm still working on that part of it. So let's talk a little bit about what we've got here. Now, the first thing I'd like to point out is that we have 4 numbers in orange. And these are estimated numbers. Now, I didn't have time and haven't gotten around to doing the range tests for the bottom 3 boards, and I didn't get a chance to range test my race board phase 1. I have a very good idea of how much range it should have based on how much battery percentage was left after track days and based on some of the rides that I did with it around the community. So my best estimate of the range for the race board is 50 miles because it had a 14S 8P of Tesla cells, which are absolutely massive and provide a ton of range in an efficient gear drive setup like that. So I think that's a pretty fair comparison, but take that with a grain of salt. The bottom 3 are also pretty close to accurate. Now, I don't have the Wave anymore, but based on the testing that I did, I estimated about 6 miles of range. I still have the Meepo V5 and the Ripple, so I will make sure to do those range tests before I present the PSPEC score in the next review, which will be the review on the Exway Flex Pro. So make sure you check that out and look in there for those updated numbers. But for the Ripple, I estimated about 5 miles of range, which is almost nothing, but it's a very small battery, and based on the riding around my community that I've done and the range test finishes that I've done with that board, it seems to be capable of about that much. There's a chance it will be a little higher, but at the end of the day, it's not actually going to affect its position in this ranking. Now, as for the Meepo V5, I have done some riding with this, not an enormous amount yet, but I will make sure to do the range test for that as well before I put out the next full board review, like I mentioned earlier. Again, there's no chance that that small bump in range off of my estimate is going to affect the position in this graph or chart. So I'm not too worried about that. But anyway, you can see the Atlas Pro comes in with an awesome PSPEC of 49.7, and technically there's no upper bound to the PSPEC score because it's based on the numbers that you get from all of the testing data. So if you have a board that's absolutely crazy, it's possible you can have a much higher PSPEC than what we have on the board right now. Now, the Flex Pro and Atlas Pro are definitely 2 boards that I would actually want to ride daily. Flex Pro being the urethane option that I would choose to ride daily, and the Atlas Pro being the pneumatic, well, besides any other DIYs that I have. Now, I will try to get more of my DIY boards on this chart, but it does take a lot of time to do all the testing data, and I don't have too much of it. So hopefully you will appreciate all of the information here, and I will eventually be hosting this PSPEC score on my website, which is currently in development, to make sure that it always has the latest up-to-date numbers for you guys to look at. Hopefully you guys went on to enjoy this performance comparison video. Now, I'm not sure if I'll make more of these in the future because they take so long to edit and put together, but I will be sure to keep recording all of the performance metrics for all of the different boards that I review. Now, this has been a really interesting comparison. I'm glad that I have all these numbers on here, but I'm curious what you guys want me to look at next. I believe next up for me will be the Hoyt Tabor, and that will be quite interesting to see how that compares to the rest of these boards. So make sure to let me know down in the comments what you thought of this video, how I can improve it, or if there were parts that you really appreciated. That would be awesome. And if you liked the video, give it a like and get subscribed to make sure you stay up to date with all the latest performance comparisons on boards in today's market. Stay safe, keep on riding, and peace out.